In this video, we're going to take a look at determining the intervals with which the graph of functions suggests that it's going to be increasing, decreasing, and constant. And then we're also going to be taking a look at relative maxima and minima of the graphs of functions. Be forewarned that the definitions that I'm going to use, they look a little intimidating, but in reality, we're going to be doing things that aren't too difficult with respect to the graph. And remember, we're just looking at the graphs and we're identifying these things. If we were to do this algebraically or analytically, we'd have to have at least a semester of calculus to be able to determine a lot of these things. So, but just from the graphs, it's going to be pretty easy for us to do. Now, let's get through the scary stuff first. A function's increasing on an open interval I, okay, so basically from like something like from -1 to 5 or something like that, if the previous y value is less than the next y value, for every single x in that interval, where x goes from x1 to x2, so previous x, next x. All right, so basically what that means is that if the previous y value is less than the next y value over an interval, that means it's increasing on that interval. All right. If we look at the graph, though, it's a lot easier for us to be able to see what's going on here. So take a look at this interval, okay, from x1 to x2, and we notice the function, the y value keeps getting bigger, okay? So that means that it's increasing on that interval. Decreasing basically means that the same thing's happening, but it's getting smaller. The y value keeps getting smaller. And so if we have like a y1 here is greater than the next y value, so y1 greater than y2, that means that it's going to be decreasing on that interval as long as x keeps getting big. Constant basically means that we have a flat line. Okay, so right here, we see that the function is constant. In fact, it's constant over a larger interval, but from x1 to x2, it's certainly going to be constant. Now, maxima and minima, basically maxima and minima are the same thing as relative maximums and relative minimums. So they're the lowest and the highest points on functions in a given interval. So from B to A, it looks like that right here, this is a minima. And we use the phrases relative minimum and minima interchangeably. And same thing with relative maxima, maximum, and maxima. All right, so if I do use those interchangeably, they mean the same thing. But notice that we have high points on a function and lowest points on a function, okay? These points right here, these are called points of inflection, where basically it changes from increasing to decreasing, right? For those of you that have to take Calculus 1, you'll see that, okay? But in this course, we're just looking at the graphs. We're not trying to figure those out analytically. So let's take a look at some examples to determine where functions are increasing, decreasing, constant, and then the maxima and the minima of functions. So taking a look at this function and remembering that arrows mean that it's just going to keep going like this forever. This function looks like it's getting smaller and smaller and smaller. Okay, so the y value keeps decreasing until we get to right about here, and then it looks like it's going back up. So that point of inflection right here is going to be at the point -1, -4, right? So it's decreasing from, or increasing, excuse me, where it's going up. In other words, the y values are getting bigger from -1 up to infinity. And when we plot the values for increasing, decreasing, we're always looking at the x values for which it's increasing and decreasing. So we're going to have from -1 to infinity. And then for decreasing, notice it would just keep decreasing everywhere from -infinity until we get to that -1. All right. Every time we do these sorts of things, or whenever we find these intervals, we're always going to use open parentheses. All right. Unless we have like some solid dots and we have like functions that aren't infinitesimal. There are no intervals of constant, okay? The only place it looks like it's going to be constant is right here at this point, but that's like one singular point. In other words, that point of inflection. So there are no intervals to where it's constant. Now, relative maxima and minimum, all right? So we're looking for a place where it's the highest point on the function, but for a maxima. But notice, guys, that this just keeps going up and up and up forever. So if the function just keeps increasing forever, that means that there are no points that are going to be maxima. Okay, so there's none of these, but there certainly is a minima. Okay, there's this lowest point right here. And so the minima is generally going to be the y value. Okay, so the minimal or the smallest value for this is going to be -4, and it's going to be at the point -1, -4. All right, so that's how we can go ahead and take a look at the graph and determine some of these things. Right. So several more examples of this. Okay. Now this one is finite in one direction, but then it gets infinite in the other. Okay, so where is it increasing? Well, it looks like to me that the y value keeps getting bigger at least over the domain of the function. So notice that we start at -1, and it is inclusive because you have that solid dot, but then it just keeps increasing forever. Right? So it just keeps going up, 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 keeps getting bigger. In other words, if we look here and we look here, the y values are bigger. So this is y1 and this is y2. And notice that those values are bigger all the way over this thing. All right, so since it's, and then over the domain, is there anywhere where it's decreasing? Well, there's nowhere where it's doing like this sort of behavior where it's going down. Okay, so that means that there are no points at which decreasing. So we're going to say none. There's no places where it's flat. Okay, so like if I look here, it's not flat, it's not flat, it's not flat. So there are no points to where it's going to be constant on the intervals. Again, maxima, what are the highest points? And well, it looks like that it's just going to keep going up forever. So I could keep drawing it like that, and I could never necessarily find where the maximum of the function is. So there is not going to be a maximum of the function, but the minima, the smallest point, because it's a closed dot, is going to be right here at -1. Okay, so it's -1, I'm sorry, at 0, because we're looking at the y value, excuse me. So it's going to be 0 at the point -1, 0. Okay, so remember for maxima and minima, we're always looking for the y values. Okay, so what are those maximum and minimum values? All right, so it might be helpful for you to take a look at these two and try to do these on your own. Okay, and then maybe pause the video, and then once you've gone through, to maybe check your answers with me. Okay, so I'm going to go ahead and do these now. So where is it increasing? Well, I take a look at this and it doesn't look like that it's increasing anywhere. Okay, in fact, it looks like as we trace from left to right, that the function just keeps decreasing the entire time. All right, so looks like there's no intervals of increasing, but decreasing, it looks like, yeah, it's going to decrease forever, except at these points where it's just going to kind of flatline, right? And we have these solid dots. And so where is it decreasing? Well, it looks like it starts at -4 and then it stops decreasing at 2. So -4 to 2. Now there's two intervals where the function is going to be constant if we look at this. So this interval right here, and again, that's going to go forever. One interval is from -infinity up to -4 inclusive, okay, because there's a dot. All right, and in fact, maybe we should just go ahead because that's a point where it's neither constant. It's basically that point of inflection. We're going to say about -4, and then there's another interval. So we put a union symbol there, and it starts flatlining again right here at 2. So 2, and then it just keeps going forever to infinity. Maxima and minima. All right, so what's the highest point on this function? Well, it's right here at -4, or I'm sorry, at excuse me, at 2, right? So there is a maxima at 2, okay? And there's not really a point, it's just the highest place, all right? So there's not really an ordered pair as to where it's going to be the maxima. And there's certainly a lowest point right here at -2, all right? So when we talk about maxima minima, again, it's the y values, okay? So there's a minima at -2 for this, right? And then finally, another one that's a little bit tricky because there's a lot of places where it's increasing and decreasing. So it looks like it's increasing. And again, think of this as -5, right? So it looks like that we're increasing until we get here. And then it looks like it's increasing again from here to here. And then it's increasing again here. So there's actually 3 intervals where it's increasing. So it's going to be from -5 to -4. And then it's going to pick up again from -2 to 0. And then finally, it looks like it's increasing from 2 to 4. Now, where is it decreasing? Well, everywhere where it's not increasing for this particular example. And so if I go through and trace this, and I'll use a different color, make it a little bit easier, right? It looks like that decreasing starting here and going down, down, down to right here, right? So that's going to be from -4 to -2. And again, we look at the x values, and then it looks like it's decreasing again from 0 to 2. And then finally, from here to here, it looks like it's decreasing again. So from 4 to 5. All right, so lots of places to where this thing's both increasing and decreasing. Now, the good news is that there is no place to where it's going to be constant. Okay, so none. The highest possible value we have is at 4, and there's several points to where it's a maximum, and that's fine. Okay, so relative maximum is going to be at 4, and then the lowest points are going to be here at -4, right? And some people might consider right here at these endpoints to be minimums as well, all right? But in the given interval, all right, it's not necessarily a point of inflection, okay, because it's not going up nor down. So we're just going to keep it like that, okay, and just say it's going to be -4 to 4. So hopefully this is helpful for you to be able to identify increasing, decreasing, maximum, minimum. Two more topics in this section will be done, one of which is piecewise functions, and then the other one, which is going to be the hardest one, is going to be the difference quotient. Okay, so hang in there, we're almost done with this section.